Hello and welcome to this video tutorial from blendercookie.com. My name is Bartek Skorupa, and in this video I will show you how to create such image. I will not be focusing on all of the steps of the process, but only on one aspect of this image, which is creating the mist effect, or in other words, aerial perspective. In this scene, everything except the sky are the 3D objects, and it's been rendered using Cycles render engine. To make our lives a little bit more difficult, I used the camera depth of field. Here are my camera settings. I have set the focal point somewhere here on this windmill. I have also used the motion blur here in the render settings. So what we can see here doesn't come from compositing vector blur, but it's a kind of real motion blur from the camera. I mentioned at the beginning that everything here in this scene except the sky are the objects created in Blender. But in fact, I didn't create any of this. I used two files that I downloaded from blendswap.com. So here it is, blendswap.com. I selected the blends, categories, and I chose landscapes. And the first file that I found interesting was this one. Here it is, Windmills by Gotten22. I downloaded this file, changed the positions of the objects a little bit, position of the camera, etc. And I felt that something was missing in the background, so I decided to add some mountains there. I could of course use some photograph, but instead I decided to use another file from BlendSwap, and it's this one, Snowy Mountain Landscape by Galdor. And this is a very interesting file worth downloading and analyzing, because you will notice that everything here, well, almost everything, when it comes to materials, is created with almost no use of textures. And here is the setup of the material of those mountains, and I sort of understand how it works, but to be honest, I will need a little bit more time to analyze this and really understand what's going on here. So here's the scene that I rendered. Those elements here come from the windmill file, and those two objects are the mountains from this file. And the sky is just a photograph. Okay, let's now focus on the topic of this tutorial. Aerial perspective, this mist that we can see here. Let's take a look at some reference images. When we go through the images of landscapes, we can see that they all have something in common. And that is the aerial perspective. When we look at the landscapes, we notice that the objects change colors, change their looks, depending on the distance from us. And it's caused by the presence of the air. Let's take a look at some other examples. Here we have some fog. Here it's more subtle, but anyway we can notice this effect. Here we have some example of the foggy scene. Here as well. Here we have a lot of strong colors, but as you can see, the further we go, more aerial perspective appears. Another example, and another one. Completely different style, but still we have those differences depending on the distance. Another one. So as you can see, it's everywhere. So let's go back to Blender and try to recreate this using the tools that we have to our disposal. Okay, so here's our final image, but calling it final is way too much. It's rather obvious that it needs some work. When we take a look at those trees here, it's noticeable that it's populated using just one single object. So I will need to introduce some variations here. When we look at this area, it also doesn't look very good, but it's only because the author of this file didn't intend to show it this way. So he simply didn't have to work on it any further. I'm also not happy with the material of the windmills, but let's not worry about those details at the moment. Let me first show you how this image looked like without this mist effect. Here it goes, and here we have the original render without the sky. Okay, let's first take a look at the setup of the compositing nodes. As you can see, it's much less complicated than my usual compositing setups, but let me go through this quickly such that you understand what is going on here. First, let's make our backdrop a little bit smaller and move it a little bit away. I will hold down Alt, middle click, and simply drag it down there. Here, in this bluish frame, we have our sky. It is just an image and it looks like this. Here I have the scale node, and it's just to make our image fit to our render size. Then I blurred it a little bit and applied a very simple color correction, so it's just a curves node, which makes the image darker. So this is just the sky. And the output of it goes here to this node, and this one is just a simple mix node. Shift A, color, mix, standard mix operation. The sky is attached to the upper input, and to the lower one I have plugged our render that looks like this. And that's the result of mixing them. As you can see, our render has the alpha channel, and when mixing it over the sky, I want to make use of this alpha channel. That's why here in this mix node, I have turned this checkbox on. When I turn it off, it looks like this, the sky disappeared. But when I turn it on, everything is fine. Okay, now here, in this frame, I have just 3 nodes that introduce the final color correction. Let's now analyze the render, something that goes into the lower socket of this mix node. Here I also have the standard mix node. As you can see, it's muted right now, and it's just because I wanted to show you how the image looks like without the aerial perspective. Let's unmute it, let's hit M. And here I am mixing the source image, I mean the source render, which looks like this, with the image that looks like this. And I used some factor to mix those 2 images together, and it's rather logical that I used the Z-pass, but it's not that simple. Okay, but let's first analyze what this image represents. This is color-corrected original render. Let's again take a look at the original render. And you may probably notice that here we have some problems with fireflies. That's why before I did anything with this image, I passed it through the speckle node. And as you can see, the fireflies went away. Let's take a look before. Here we have some problem. And after. And the problem's gone. Okay, so here we have just the reroute node. And one of the links goes straight here to this mix node. And the other one goes this way, where I color correct this, and the result of this color correction goes into the lower socket of this mix node. So I am mixing this with this, using properly created Z-pass as the factor. And here's the Z-pass that I am talking about. Let's not worry about this black area here, because this will be covered by the sky. And anyway, the original render has the alpha channel, so this area will not be taken into account. Okay, let's take a look at it once again. So the darker the factor, the more of the original render will be taken. And here in this area, where this factor is brighter, more of this image will be taken. So here goes the mixture. And that's how the mist is created. Okay, so then we mix it on top of the sky, and after all of those operations, I introduced some final color correction. Now let's focus on the Z-pass. We will use it to control our mist effect. This is how the standard input render layer looks like. I don't like using input render layers. I prefer to pre-render my image and work on the rendered version of it. I choose to render to OpenEXR multi-layer file format, so I simply render the image. When it's done, I simply hit F3 and save the result. And then in Node Editor, I can hit Shift-A, Input, Image, Open, or I can also take this result directly from the file browser and drop it onto the compositor window. And here it goes. Let's delete it because I have another version already imported here. So this is my input render layer, and this is the multi-layer OpenEXR that represents exactly the same image. As you can see, the outputs of it are different than the outputs of this one. Here in the input render layer, as you can see, we have the Z depth, and it's called Z, and here in this file it's called depth, but they represent exactly the same. Okay, so let's get rid of this input render layers, we don't need it anymore, and take a look at the depth pass. Control Shift click once, the second time, and this is how it looks like. Completely white image. When we are using the backdrop and hit Alt and left drag over the image, in this area here we will see the values of the colors. And as you can see, this image is not exactly the same all over the picture. Those values change. The visual range is between 0 and 1, and as you can see, the red, green and blue channels are way beyond 100 or even more, here some ridiculous values. So it's simply impossible to view this image. That's why I will pass it through vector normalize node. Let's plug it here and we begin to see something. Normalize node takes all of those ridiculous values and simply compress them to the range between 0 and 1. So here we have values very close to 0 and here we have the values close to 1. But it doesn't seem useful at all, does it? Take a look at the edges here or here, and here is a complete disaster. Why doesn't it look like this? This one looks much better. And after proper adjustments we can easily use it as the factor for creating the mist. So let's simply pass it through the converter color ramp. Let's plug it here and we can very easily do something like this. To push the beginning of the mist a little bit further, we can move this slider, or let's leave it here at the end but simply change the color of it. Let's make it a little bit darker. So just proper adjustments of color ramps will give us exactly what we want. But unfortunately the standard ZPass doesn't look this way. And the reason for this is that it's not anti-aliased. And unfortunately, it seems not to be possible to convert this into this. This one needs to be created from scratch. Anti-aliasing is happening during rendering the surfaces with shaders. So we need to create the special kind of shader that will return the value of the Z depth as the rendered color. When we set it in materials instead of in compositing, we will get nicely anti-aliased image of the Z depth. This special kind of material needs to replace every single material in our scene. But at the same time, we don't want to destroy all of the materials that we have here. So we will make use of the render layers. By default, here in the render settings, layers panel, we have just one render layer. It's normally called simply render layer, but I have renamed it to main. When I add another render layer, I simply can hit this plus button. This will mean that our image will be rendered twice. First time with all of the settings that we set for the main render layer, and second time using the settings for this second render layer. Let's call it Z. Down here we have the option material, and when we choose any of the existing materials here from this menu, it means that every single material in our scene will be replaced by this material. And this will happen, of course, only for this render layer. This one will use the materials that are applied to the surfaces. Okay, let's select the Z render layer, delete this material for the moment, because we didn't yet create this material that should be used as the material override for this render layer. In order to create it, we can select any object in our scene, go to the materials panel, add a new material slot, and don't worry, it won't be used because we will not assign any vertices to it. We will simply use this slot to create the material. Let's add the new material, let's call it Z, and let's begin creating it. Our goal here is to get the value of the Z depth in the final color of the pixel. Let's switch the node editor window to materials, and we have the initial setup of the Z material. Let's delete the diffuse BSDF, because we will definitely not use the diffuse material. And now Shift A, input camera data, and here we have all of the information that we need. View Z depth is exactly what we want. But as you can see here, we also have something that is called view distance. The difference between them is as follows. Let's imagine that here is our camera. If here we have some surface, and here we have our camera and it's facing this surface, we can measure the distance between the camera and all of the points of this surface, or we can measure the distance from this surface and the camera plane. So here we have the virtual plane of the camera, and the distance between this surface and this surface is exactly the same in every single point of those surfaces. And this is the view Z depth. And the view distance is a little bit different. When we analyze the distances between the points on this surface and the camera, here the distance is greater, here a little bit shorter, shorter, and that's the view distance. So we need to make a decision which one we will use, this one or this one. Those differences are not that significant, but it's good to be aware of them. Okay, so let's say that we chose to use the view distance instead of view z depth. We cannot, of course, plug it directly here to the surface. We have to pass it through some shader, and the best one for this is the emission shader. Let's add it and plug it here. But that's of course not the end of the setup, because this way all of the meshes will not only get the colors that we need, but will also react between one another. They will simply emit light that will influence other objects. And this is not what we want. So let's mix it with something else. Shader mix shader. Let's plug it here. And I will plug my emission shader into the lower socket of this mix shader. And to the upper one, I will plug nothing. And simply to stress that I really want to plug nothing here, I will use the shader holdout shader. And this shader means nothing. I don't mean that it doesn't mean anything. It means nothing. So let me plug it here. When this shader is used, the objects using it will simply be not visible for anything. Okay, so I want to mix nothing with the emission shader. That's color is exactly what we want, which means the view distance or view z depth. Let's maybe this time use the view z depth, so it will be easier for us to compare the result that we get with a standard z pass. Okay, so now I want to make the emission shader to be visible only for the camera. And in any other case, the holdout material should be used. So when the surface is visible for the camera rays, it will use this shader, and if it's seen by any other kind of the rays, it will simply return nothing. So let's add the input light path node and plug is camera ray to the factor. Control H, and that's all we have to do. So the material is ready. Let's complete the render layers setup. Let's choose this material from this pop-up, Z. We don't have to use environment. No additional render passes needed. And we're ready to render. Creating additional render layer adds to the render time. That's obvious. But this is such a simple material that it renders almost immediately. Let's take a look. Let's lock this so only this render layer will be rendered. Hit F12. And as you can see, it takes just a fraction of the time that is needed to render the proper render layer, the main render layer. In the final render, I of course rendered both of the render layers, so I need to deactivate this pin. So here I have my image, OpenEXR multi-layer. It behaves almost exactly the same as the input render layer. Let's take a look at it. Let's now duplicate it. And here I will use the Z render layer, so let's change it here. Let's also change the label of this node, N, and here let's call it Z. And here we have combined and depth. We are interested in depth in general, but our depth in this render layer is represented by the combined. So this is what we will be using. Let's pass it through the normalize node. So we have something like this. Normalize node destroyed the alpha channel. And we may have some issues because of that, so let's try to fix it. That's the original Z-Pass. We can extract the alpha channel from this image and apply it to the result of the normalized node. So let's add the converter separate RGBA, connect it here, and here we have the access to all of the channels. This is the alpha channel. Let's hit Ctrl H to hide all of the other sockets. And let's now add converter set alpha. Take the result of normalized node and plug it to the image input, alpha to the lower input, and that's the result. Let's now take a look at the RGB channels ignoring the alpha, so let's turn this option on. And it's rather logical that here in those areas we should have white color instead of black color. So we can simply add the mix node and mix the solid white color with this output. Let's take a look at the result. But we need to take into account the alpha channel of this image. So let's turn this option on and everything seems fine, but when we take a look at the edges here, we have some issues. And this is because this image is pre-multiplied. So we have two options. We can unmultiply this, or instead of mixing it with the white color using the mix node, we could also use the color alpha over. Because mix nodes expect straight alpha and alpha over expects pre-multiplied alpha. So I will plug this one to the lower socket of the alpha over node, and now when we take a look at the result, you see that we no longer have problems on those edges. Let's compare. This is the result of the mix node and this is the alpha over. So I will simply use this one instead of this one. Now to control it, I will also pass it through the color ramp. Let's plug it here, but I will not adjust it yet. Let's leave it as is and take care about our main render. This is how it looks like. Let's activate the display of the alpha channel. I want to mix it with color corrected self. But first let's despeckle, filter, despeckle, plug it here, and let's add the color mix node and plug this one to both of those sockets, F, F, and we are done. Let's take a look at it. Of course, nothing changed. Let's maybe shift left drag here and move this reroute node somewhere here. And when the objects are further away from us, the colors begin to be a little bit washed out. We begin not to see the blacks. So we can simply add the color RGB curves node. Let's plug it here and do something like this. Maybe not that strong. Now let's maybe move this one and those ones a little bit away. Use the Z pass as the factor here. Now let's select the color ramp. Let's hit N. This way we can control the color ramp here or here. And I will control it here. So now I can simply move all of those nodes away. My color ramp is still selected, so I can control it. And at the same time, I clearly see the backdrop. So let's move this point here. So I am pushing the beginning of this mist a little bit further. Now, when I change this color from white to something a little bit darker, I kind of tone down this effect. Now I would need some sky, so let's move all of those nodes back here. Take those two, move them away, and let's add the input image and select the image. Take a look at it. And the first thing that I will do will be to make it fit to the render size, distort, scale. Let's choose the render size, plug it here. And I have three options: stretch, fit, crop. Let's maybe crop. And I need to mix it with my render. So let's simply maybe duplicate this node, this mix node, plug it here. Now it's mixing the sky with a white color, but I want to use this output here. Let's activate, use the alpha channel of the second input. Let's maybe see what would be the difference if I, instead of using the mix node, used the alpha over node. Let's shift left drag here and plug this one here and this one here. Take a look at the difference. So here's the result when we are using the mix node. Here's the result when we are using the alpha over node. And it seems better, so let's use this one. Let's get rid of this mix node. Maybe this reroute, Control X. The sky doesn't seem to fit. Let's first blur it a little bit, filter, blur. Let's choose the fast Gaussian, plug it here, and set it to something like, I don't know, maybe 2 for each axis. Maybe 4. And now we should either make it darker or brighten all of the rest. So I will first make the sky darker. Let's add the color RGB curves, plug it here, and simply do something like this. Maybe a little bit more. Now here, to make this mist a little bit more believable, I could maybe multiply this result by some color. Or maybe not. Let's try something different. In this case, I decided to mix the original render with the color-corrected version of it, but I could also add some solid color to it using the Z-pass as the factor. So let's add the input RGB and maybe plug it here to the lower input of this mix node and change the operation to add and see what happens. Oh, this is extremely strong, but I will change this color to something a lot darker and a little bit warmer and take a look at the final result. Maybe instead of making it warmer, let's make it cooler. And this seems more believable. I don't know. Now, we of course can introduce some overall color correction on the result of all of this. So let's maybe add the color balance, plug it here, and push the lift towards some cool color and make the highlights a little bit warmer, brighter, brighten the gamma. We can as well come back to all of those adjustments. The setup is ready, so now it's just a matter of tweaking it. And it all is possible thanks to proper creation of the Z-pass. As you can see, the result that I achieved right now is completely different from the one that I showed you at the beginning. But that's how it works. I would of course add some vignette, glows, maybe some grain and some other final touches, but that's not the topic of this tutorial. I would leave you at this point. That would be all from me. Thank you very much for your attention. Bartek Skorupa for CG Cookie. Take care and see you next time.